I'm Angela Dodd, and this is Related Rates. So the definition of related rates is related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities, whose rates of change are known. Problem 1. A water tank has the shape of a circular cone with base radius 2m and height of 4m. If water is being pumped into the tank at a rate of 2 minutes cubed, find the rate at which the water level is rising when the water is 3m deep. So the first thing we're going to do is we're going to draw a picture. So here we're going to go and sketch the cone. So we draw a circle, drawing the cone. Okay, we know that the radius is 2m, and we also know that the height of the water is 3m. We know that the height of the entire thing is 4m. So the volume with respect to time is equal to 2 meters per minute cubed. We're looking for the height with respect to time when the height is equal to 3. The volume of a cone is as follows. V equals 1/3 pi r squared times h. In order to eliminate r and the use of h alone, we use the similar triangles in the sketch to form r over h equals 2 over 4, thus h over 2 equals r. The expression for v becomes v equals 1/3 pi times h over 2 squared times h, which equals to pi over 12h cubed. Now we can differentiate each side with respect to t.
Good.
So now we're going to find the derivative of the equation in order to find the value with respect to time. So dv over dt equals to pi over 4 times the height squared dh over dt. So that becomes, once we plug in what we know, 2 equals pi over 4 times 3 squared dh over dt, which equals 2 over pi over 4 times 3 squared. So dh over dt, which is the height with respect to time, is equal to 8 over 9 pi. This means that the water level is rising at a rate of 8 over 9 pi, or 0.28 meters per minute. Problem 2. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters per second cubed. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? So we're going to begin by identifying what we know. So we know that the volume with respect to time is 100 centimeters per second cubed. So what are we looking for? Well, we want to know the radius with respect to time when diameter equals 50 or the radius equals 25. Remember, the rates of change are derivatives. Radius and volume are both functions of the time. T. The rate of increase of the volume with respect to time is dv over dt, and the rate of increase of the radius is dr over dt. The formula to find the volume of a sphere is as follows. V equals 4 over 3 pi r cubed. So now we're going to find the derivative of this equation, and then plug in what we know. So the derivative of v equals 4 over 3 pi r cubed is dr over dt equals 4 pi r squared dr over dt. As the values are with respect to time. So now we're going to solve for the unknown quantities. So dv over dt equals 4 pi times 25 squared, dr over dt. Is that a cube? So after plugging it in, dv over dt equals 100, so 100 centimeters per second cubed equals 4 pi times 25 squared dr over dt. So 100 over 4 pi times 25 squared is equal to dr over dt, meaning that 100 over 2500 pi equals dr over dt, or 1 over 25 pi. So, the radius of the balloon is increasing at the rate of 1 over 25 pi centimeters squared. Problem 3. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So we're going to start by drawing a picture and identifying what we know. So, we know that the ladder is 10 feet. We know that the bottom of the ladder is 6 feet from the wall. So A equals 6. We also know that the ladder slides away from the wall at a rate of 1 foot. So we know that dA over dt equals 1. We are looking for dB over dt, which is the rate at which the ladder slides down the wall. Because this is a right triangle, we can use the Pythagorean theorem. A squared plus b squared equals c squared. So, a squared plus b squared equals 100, as c is a constant. After finding the derivative of the equation, it becomes 2a dA over dt plus 2b dB over dt is equal to 0. Now we solve for b in order to plug into the derived equation. 6 squared plus b squared equals 100. 36 plus b squared equals 100. 100 minus 36 is 64. So b squared equals 64. B equals 8. Now we plug in what we know to the derived equation. 2 times a, which is 6, times 1, which is dA over dt, plus 2 times 8, which is b, times dB over dt is equal to 0. 2 times 6 times 1 equals negative 2 times 8 dB over dt. 12 equals negative 16 dB over dt. Divide each side by negative 16, and we get dB over dt is equal to 12 over negative 16. So dB over dt equals negative 3 over 4 feet per second. Notice that dB over dt is negative. This means the distance from the top of the ladder to the ground is decreasing at a rate of 3 over 4 feet per second. The top of the ladder is sliding down the wall at a rate of 3 over 4 feet per second. Okay, well, this concludes the tutorial of related rates. Thank you for watching.